Well, hello everyone, and welcome back to Adrian's Digital Basement. On the bench today, I have an Apple IIe hooked up to my Commodore 1084 monitor, and it's hooked up via RGB TTL. The way that's possible is inside this Apple IIe, I have a Video 7 Enhancer IIe, which is an RGB card that plugs into the auxiliary slot. It gives the computer the extra 64K of RAM for modes like double high res, but it also outputs a nice clear TTL RGB signal, which is compatible with any CGA monitor like the Commodore 1084 here. The problem is, a lot of people these days have their old retro computer that they want to use, but finding something like a CRT that works and isn't broken or too expensive to even buy is kind of difficult. But lucky for us enthusiasts, seems there's a bit of a renaissance going on when it comes to new hardware coming out for the Apple II that's both inexpensive, it's open source, and it will simplify the connections of this machine to more modern hardware. And that's what I want to talk about today, which is this very inexpensive and simple card that plugs into the Apple II and actually gives you HDMI compatible output right from your old Apple II computer, just like this IIe. And you won't have to go looking around for an old monitor that supports TTL RGB if you have one of these cards, or composite video, or even VGA, which of course is getting harder and harder to find these days, because this little card supports hooking up with the most modern standard through a normal HDMI jack. So without further ado, let's take a closer look at this card. Before I dive into how this HDMI display card works for the Apple II, first I want to touch on the way the Apple II line of computers generates its color graphics. Now there's a couple caveats here. The Apple II GS is excluded because it actually has native RGB, but if you look at every other Apple II ever released, the computer really is at its heart a monochrome computer system. Nowhere in the video subsystem inside the computer is there any sense of color. The way color is generated was a hack, so to speak, by Steve Wozniak on the way NTSC color actually works. And what the original Apple II did is it would output a monochrome signal, but then Wozniak added the NTSC color burst into the video output, which would then turn on the color decoding circuitry inside the connected display, whether it's a TV or any kind of monitor. When you look at the broadcast television standard in North America, it was originally a monochrome signal as well. It had shades of gray, but it had no color information. The way NTSC added color information to a monochrome video signal, one that was backwards compatible with black and white and monochrome displays, was it added some high frequency information into the video signal, which you can see as dots when you're looking at a monochrome monitor hooked up to a color signal. The color decoder that's inside the more modern displays that support color will take those dot patterns that are overlaid on the video signal, and it will turn those into different colors based on the phase and intensity of those dots. So the hack that the Apple II employs to get color video is it draws vertical lines that coincide with the dot pattern that NTSC color uses, and it's able to trick the decoder in the television to think that the signal coming out of the Apple is actually in full color. There are some undesirable side effects with doing this hack though. Anytime the color decoder is turned on in the display, any vertical lines that appear, including ones on letters like the text mode, are going to show up as color around the letters. And in the parlance of the Apple II, that is known as color fringing. And it can be especially bad if you have single width fonts displayed with the color decoder turned on your set. You get a lot of purple and green fringing around all the letters. The reason why I'm talking about that is because if you're going to hook a display up to your Apple II that does not use normal NTSC artifact color decoding, then you have to use some additional intelligence to take the bit pattern that the Apple II is storing in its video memory. Remember, it's just monochrome pattern of bits, and convert that into a solid color that you could then display on something like an RGB monitor, like the 1084 I had up here earlier, or even something more modern, like an HDMI display hooked up to a card like this. So looking inside the Apple II I was just showing at the intro, and we pop out the auxiliary card here. This is the Video 7 Enhancer IIe card. The company Video 7 made a whole line of RGB cards for Apple II computers, and this is probably one of their later ones. What's interesting about this card is it's really got two components. It has this RAM here, which is the auxiliary RAM used to bring your IIe to 128K, and a couple support ICs, and then there's this chip right here. Well, if you can believe it, the entire RGB solution of this card is really self-contained in this one wafer scale IC. The rest of the stuff on here is strictly for adding the additional auxiliary memory. And what's really interesting about this particular solution here is they actually made a version of this for the Apple IIc that plugged onto the back of the machine and gave the Apple IIc RGB as well. Now the Apple IIc on its 15-pin connector on the back, you might think it has RGB on it, but it doesn't. It actually outputs a serial stream of all the bits of whatever video is being displayed, and then it has some extra sync signals. And those same signals are available inside the IIe on the auxiliary slot, and that's exactly what this chip is reading. It's reading that stream of data that's coming from the shift register that converts the RAM on the motherboard into a video signal. Inside this IC is all that magic that converts the bit patterns that I was talking about, those vertical lines, into the color information that is then sent via TTL RGB to the monitor connected to the back of the computer. If you want to know more about this card, I actually created a post on the VCF forums where I show some more pictures of this front and back, talk a little bit about how it works, and actually talk about one of the modifications I made to this card to make it work a little bit better. So back to the original topic at hand. If you want to hook this computer up to a modern television using HDMI, then you're going to have to buy a little box that converts composite video to HDMI. And there's a whole bunch of those available on eBay, Amazon, stuff like that, and they're very inexpensive. The problem is the video quality really kind of sucks. And then the other issue is you're going to get all that color fringing that I talked about because of the way the artifact color works on the Apple II. You have to remember that the Apple II came out in 1977, so the way the video works was really designed to work with televisions of the day. And when you're using a CRT monitor plugged into this, it works about as good as it can, pretty much no matter what the CRT is. But when you plug in modern digital stuff that tries to convert the composite video signal, often it's just hit and miss with the quality. Now, one way you can hook up an Apple II to modern displays is using an RGB to HDMI. That's what this is right here. I've talked about this a whole lot on the channel. This particular one has a TTL video input and it outputs HDMI right here, and you just power this thing up. And inside is a Raspberry Pi Zero, but there's also an extra carrier board that has a CPLD on it that digitizes this signal coming in and then converts it to HDMI. Some of the issues with this device though is you have to procure yourself a Raspberry Pi Zero, which can be kind of difficult sometimes. They seem to go out of stock a lot. But worse than that, the CPLD that's used to convert the TTL video signal into what the Raspberry Pi needs apparently is really hard to get right now. So from my understanding, RGB to HDMIs are kind of in short supply. There's one other problem though with using it on something like the Apple IIe. There is no easy way just to connect this up to the IIe because this thing does not directly expose the signals that this would need to decode the video signal to then output HDMI. The RGB to HDMI actually is very similar to the way this wafer scale works on this Video 7 enhancer, where it takes the serial data that's coming out of the shift register plus the sync signals, and then it converts that into color information. If you have an Apple IIc, it's very easy to plug an RGB to HDMI into that because you can simply use a cable like this that just plugs into the 15-pin connector on the back, and then it just goes to a normal 9-pin here, and then plugs into my RGB to HDMI, and you get a nice clear video signal. So for IIcs, the RGB to HDMI is still one of the better ways to get video out of that because obviously you don't have expansion slots, you can't use this HDMI card that I'm about to start talking about. So let's start talking about this particular project right here. This is the A2DVI, Apple II to DVI. And as you can see here, this is using a Raspberry Pi Pico, or the RP2040 there, and some level shifters. That's all that's going on this card. You're using a very easy to get off-the-shelf microcontroller and a carrier board with some simple and easy to get level shifters, which convert from 5 volts down to 3.3, which is what this natively runs at. The funny thing is the RP2040 used here is actually 5 volt tolerant. So you could surely just hook this directly up to the bus and it would probably work fine. I'm not really going to talk about whether you should or should not be using these level shifters, but I've been seeing other projects coming out lately that are using the RP2040 that aren't using level shifters, and they're doing it on old TTL-based computers like this, and things seem to work without any issues. Now, I actually hadn't really heard about this particular project before, and I came across this at VCF Midwest that I was recently at in Chicago, and this was given to me by Chris, who has the website 8bitdevices.com. Chris is a huge Apple II fan and had this awesome table set up at VCF with all these awesome things for the Apple II. And well, he was showing off this card and offered me one. And I said, yeah, sure. Okay, that sounds cool. Now, if you regularly watch my channel, you know that I talked about a similar card to this that uses a RP2040 as well, but it offers a VGA output instead of HDMI. But what really shocked me about this card is a year ago when I was looking at the Apple II VGA card, if you had said to me, oh, did you know that the RP2040 could output a HDMI compatible signal directly from it with no additional hardware? I would have thought, nah, that's silly. How could that be possible? All the other full Raspberry Pis are running system-on-a-chips from Broadcom that are designed to run Linux and be fully functional computers. They have HDMI output. In fact, the newer ones have dual outputs and USB and all sorts of other things. Meanwhile, the RP2040 is like a part that costs $1, and while it has an ARM Cortex core in there, I think it has 2 of them actually, it's not designed as a full computer. It's really more like a microcontroller, just a powerful one. From what I can tell is happening here is instead of just outputting a bunch of GPIO lines that then use a simple ladder DAC using resistors to create a VGA signal, they're bit banging an entire DVI video signal, a digital video signal, that of course is HDMI compatible, or rather HDMI displays are compatible with DVI. And this outputs 640 by 480 display, and I don't even know what bit depth it is, and it goes right to your monitor, right out of the Raspberry Pi with no additional chips. There is nothing special happening on this card. The HDMI connector goes directly to the GPIO lines that is connected to that little RP2040 processor. And these ICs, as I mentioned before, are just doing level shifting from the 5-volt bus on the Apple II and bringing them into the RP2040 as well. Now, looking at the back of this thing here, you can see that this particular board is actually one that Chris has re-laid out. And if you look online, you can buy these from other people, and they look a little bit different. They all work the same way because the schematics and the entire project is fully open source. So you could design a new version of this that actually takes the RP2040 and puts it right on the board to save money and not have to attach one of these off-the-shelf $5 RP2040 boards. What's so freaking exciting about this kind of stuff is that this is a software-defined card, and I've talked about this a whole bunch. This is the renaissance that's going on right now. Software-defined cards mean that the heavy lifting of everything that's going on that would normally be in logic chips, like in this wafer scale chip that's on this RGB card, is done in software that's running on the RP2040. So to add new functionality to this, it's as simple as just plugging the USB cable into here, copying the new firmware over, and there you go, you're actually done. And that brings up a really interesting point about the way these types of video cards for the Apple II display their video or generate the video. They aren't working in the same way as this card, which is taking that shifted bit stream that comes right out of the video hardware and then interpreting it and then outputting it to your monitor. This card actually can plug into any of the slots on the motherboard, well, any of the normal expansion slots. And what it does is it snoops all the activity that's happening on the bus, and it looks for activity of the CPU right into the main memory on the Apple IIe. The Apple IIe does not have dedicated video RAM, and the actual video buffer is in the main memory. And it's the other circuitry on all Apple IIs that cycles through that memory buffer inside the main memory and then displays it out the video port. Even if you take the CPU out and you turn the computer on, you're still actually going to have a video image displayed. It's just going to be garbage because that's what's in the RAM when you first turn on the system. Well, all of these projects basically recreate the video buffer inside the RAM on the RP2040, and anytime the CPU is writing to the video memory based on whatever software is running on the computer, this thing just replicates it into its own buffer and then outputs it. That actually means that if you have a machine that has a problem in the video output circuitry on the motherboard, but the main memory is working and the CPU is running properly, that this thing is going to output a video signal and show correctly, even if the computer itself, when you plug a monitor into this port, might not work. And what's so freaking cool about cards like this is because they're snooping all the activity on the data bus, you can create new video modes, or you could load some debugging firmware onto this, where instead of just showing you the normal Apple II display, what you would see on the composite output, you could have this point to a different place in memory, and you could actually visualize what's happening inside the RAM as the computer is executing. Cards like this are really just a blank canvas, and if you're a good software programmer, you just have to work within the limitations of the way that this card is plugged into the bus and the HDMI connector, and you could do all sorts of different things with this. All right, well, with all that said, let's take a look at what the current firmware for this card is able to do. And I'm just going to plug this into any of the slots on the motherboard here. I'm going to stick it in slot 3. Now for this particular card that Chris gave me, the HDMI connector is on this side, which means you have to have a cable that comes through the case and just loops around. I've seen other versions of this where the HDMI connector is sort of over here, and that means you could feed a cable through. It doesn't have to loop around inside the case. I also tested this with one of these HDMI to VGA adapters, and this absolutely works perfectly. This thing will actually power up this adapter because this is an active adapter, and then you get a nice 640 by 480 VGA signal out of this, which means even though this is a DVI output with an HDMI connector, it doesn't have VGA. If you do want to use it with VGA, you can pick these up off Amazon or AliExpress for just a few dollars, and it completely works perfectly. And I have this cord plugged into my HDMI switch box so I can capture the video. Is it going to work? I haven't actually tried this yet. I just plugged it into my LCD monitor here. Yep, so there we go. It's freaking working. All right, now you're noticing that there's some additional text around the border region. What that is some additional debugging that I had already turned on because I've been playing around with this card before I made this video here. At the bottom, it's showing us the program counter, the stack ID, and the 0 page. I don't know exactly what all that stuff means. And at the top, it's showing us that we're in text mode, we're in 40 column. I don't know what P1 means, and I don't know what CX-ROM means. And to be honest, I don't know what V7.3 means. I think it's all explained on the GitHub repo, but let's put this thing into 80 columns mode. Whoops, PR number 3. And now you can see at the top, it says 80 STR, so we're in 80 columns mode. And look at that, absolutely pixel perfect. Now for configuration, there's a configuration utility, which I've put onto a disk here that allows you to set up the card. Let's take a look at this. So after booting the disk, we're presented with two options, configuration menu and uploading custom fonts. Apparently, you can upload custom Apple II fonts directly into the RP2040 here, and they'll be displayed on your external display. This will have no effect of what's happening internally on your machine, of course, but if you're not plugged into the composite video output on your Apple II, then it really doesn't matter anyways. So we hit A for configuration utility and asks us which slot we're in, and we're in slot 3, and there it is. Now you notice at the top, I'm running firmware 1.3A1, and this is like an alpha firmware that isn't really out yet. And that's because I've been chatting with the main developer on this project about adding some additional Video 7 modes that this RGB card, the Enhancer IIe, supports, that it didn't seem that this project was supporting properly. So that functionality, which I'll demonstrate in just a second, should now be available on this particular card. We'll get to that in a moment. Let's just go through these configuration options first. So machine type is set to auto detect, Apple II, IIe, AGAT 7, I think that's a clone, AGAT 9, basis. These are obviously some kind of clones that this thing does support. And again, the whole software-defined hardware thing was what I was talking about, is if any bugs are detected for the way that this interfaces with a clone, it can be fixed in software. And that's just so amazing to me. The Enhancer IIe here works in the Apple IIe perfectly, but I bet you there's clones out there that are clones of the IIe that it may not work in. And there's no way to fix it because it's all in hardware. And here we can update the firmware once the bug fixes are in, and that is so amazing. One thing you notice here is you do not see Apple IIgs as one of the supported systems. And yes, currently this is not supporting the 2GS. I haven't tested this, and I don't think I read this on the GitHub repo, but it might actually work on the 2GS. It just won't support any of the additional 2GS video modes, only support the standard Apple II modes. The reason why there's a difference between the IIe and the Apple II is, as I talked about, the Apple IIe has the integrated 80 column stuff in it, while the Apple II and the II Plus do not. Those would need to have a separate card for the 80 columns to work. And currently this card, when it's used in an Apple II or II Plus, does not support 80 columns mode. I noticed there was a feature request on the GitHub repo for adding that functionality, but I didn't take a look at the issue, so I'm not sure if that's even possible, but I'm assuming it is possible. Second option here, character set. So currently it's set to 2E US character set, but you can pick different ones. And if you look down in the bottom right of the screen, notice the hash symbol becomes the pound symbol, which is like the Apple IIe released in the UK. And then we have a French character set, a German character set, Spanish, Italian, Swedish, Finnish. There is the reactive micro Apple IIe character set. And if you notice, it changes things like, look at the letter D. If I go back to whatever, this is the Apple character set. See the D character on like double high res or disabled? The vertical riser is all the way left justified. But if we look at the US reactive micro one, it's shifted over a little bit. The thing is, you can load custom fonts onto here. So theoretically, if someone made a font editor on the Apple II, that would be amazing actually. I don't know if there is one, but there obviously are ways to edit these fonts, and then you can upload them into this card. I think that's a really awesome feature. Now there's also the 2 Plus font, which you can use, which, as you notice, it shifts everything down, and that's because the 2 Plus font doesn't natively support lowercase. So what Apple did is they shifted everything up 1 pixel, and that way they could have like lowercase g or j and things like that and have the little descender. There's also an unenhanced character set. Enhanced character sets have the extra mouse text stuff, so like little symbols like apples and lines and things like that. It's possible you might have an old piece of software that's just not really compatible with the lowercase font that's on the Apple IIe, or even the enhanced font set. It might look wrong, and you can actually go and change it in here so that you can run that software properly. One thing I didn't mention is that on the card, I noticed it's on Chris's version, but it's also on the other ones, is there's a little jumper pad on here that you can then connect up to a toggle switch, and when you short the pins together, it will pick an alternate character set on this little card here. And that originally came from the international versions of the IIe, which use J19, which is right here on the motherboard. It's unpopulated on this one, in combination with a switch on the front of the computer that allow you to pick alternate keyboard maps and character sets, usually for international countries. So that functionality is replicated on this card, which would allow you to switch with a toggle switch between, say, the normal IIe character set and, say, the 2 Plus character set, which doesn't support lowercase. This is especially useful for machines like the 2 Plus. If you're using this card, you can actually run this with the Apple IIe enhanced character set, and then that means software that's using that character set on your Apple II Plus will display correctly. Normally, the built-in character generator on the 2 Plus doesn't support any of those characters or lowercase, and when things try to use lowercase, you get a bunch of symbols and just sort of, it doesn't look right. And this will allow you to bypass that. And it's option 3 here, which allows you to pick which is the alternate character set when those pads are shorted on this board. Next up, we have option 5, which allows you just to pick between amber, green, or black and white for any of the monochrome modes that are output from this card. Option 6 allows you to control whether the card does the decoding of artifact color or not. So if you have a program that is using the graphical mode, but it's generally designed to be looked at on a monochrome monitor, it might look really terrible with all the color fringing. So you can set this option to monochrome, and that means that anytime any program is using color, it will actually just display in monochrome. You know what? That has me thinking. I don't really care about selectable character sets, but what would be very useful is if I could reuse the contact pads for the selectable character set to control whether it forces it into monochrome mode or into color mode. It seems like a whole bunch of extra steps if you have a program like Music Instruction Set as an example. It doesn't use any color and it looks terrible when you have artifact color enabled. So you have to like boot the configuration disk to actually switch the monochrome mode on and then run the game or the program to make it look proper. It'd be so much nicer if you could just repurpose that switch there to switch between the color and monochrome. The next option you can turn on is scan lines on or off. Option 8 is something called Analog Render FX. And what's really cool about this option is instead of just normal artifact color decoding, it tries to actually introduce a little bit of the smoothing that a real CRT has when it's doing the color decoding. The reason why this is a cool feature is sometimes, especially in double high res, when you're displaying text and you're looking at it on a real CRT, yeah, there's color fringing, but the text is pretty readable. But then when you display it on RGB, it looks super unreadable. And that's because the artifact color decoding that's happening on cards like this, and even the Video 7, it's such a pixel perfect decoding of the artifact color that it actually makes the text look worse than it would look on a real CRT. So it's this whole give and take with the RGB sharpness versus the color decoding you're getting on a real CRT. And I feel like this option here is actually a really cool middle ground, especially on double high res. And the options you have are double low res, double high res, and then enabled and disabled. If you have it disabled, you're gonna get pixel perfect color decoding at all times, which is super duper sharp, but especially in double high res, it's going to be really difficult to read any of the text. And therefore, double high res only seems to be really the good compromise setting for it looking as good as possible. Option 9 is Video 7 modes. What this is talking about is enabling emulation of various extra features that the old early 80s RGB cards added to the Apple II. Now, this is the Enhancer IIe, which I've talked about already, but I have another one here. And this is the Apple RGB card that they actually sold with their RGB monitor. But this card's actually just made by Video 7, same manufacturer as this. And this added a bunch of additional video modes for the Apple IIe. It allowed for things like customizable foreground and background color per character on your display. Apple IIs normally just output black and white text. There's no color of any kind. And on the Apple II GS, there's actually an option to pick a foreground and background color and a border color. But you cannot set color of a particular character, not without some fancy demo coding tricks. But on this card, you can. You can set any character to have any one of 16 foreground and background colors across the entire screen. And it's all done in hardware using some additional RAM that's on this card. And interesting is this particular card, which came out after that other one, does not support that color text mode. But this card, when you have this feature enabled, it does support it. And we'll demonstrate that in a second by using the original demo disc that came with the RGB card. The next option is the debug mode, and this is the stuff around the edges that I have turned on right now. I kind of like it, but to be honest, you know, I should just turn it off, right? We can save everything we've set up here into the flash memory, and there we go. It's saved. Oh, it actually exited the program. I didn't mean to do that. And you can also load your settings from the flash memory if you've changed stuff and you meant to go back. And I think there's an about page here, which just talks a little bit about this particular card, including the 2 GitHub repos. There's one for the hardware and one for the software or firmware. And you can see right here that it's talking about how fast it has to encode the video out of the DVI connection, 3 times 252 megabits per second. When you're thinking about what the Apple II is, it's a 1 megahertz computer, merely 2 megahertz when you look at the way the video memory is working and stuff like that. And this thing is, whoa. All right, yeah, there's a little bit of a fault with my Apple IIe right now, and I haven't traced it down yet. Sometimes when you bump the computer, which I did when I put my arms down onto it, it caused it to crash. It can crash or reboot, and it sort of does both. So anyhow, back to this screen here. You can see at the bottom there, it says the A2DVI is based on the other projects, the Apple II VGA project by Mark Akins and David Cooter. And I showed off David's version of the Apple II VGA card on the channel before. And that card actually does some additional cool stuff, like it can emulate a CPM card, and I think there's some other functionality it can do now as well. But the main video decoding subsystem has been ported into this project, and then of course this is combined with the Pico DVI project right there by Luke Wren. And bringing all that stuff together gives us this with the HDMI or DVI with HDMI compatible output on a freaking Apple II. Back to the main screen here, we have a debug here, which talks about the number of bus cycles and the overflow and the number of frames, 80,000 frames, I guess, since I rebooted the computer. And every time I've ever looked in here, I've never seen any bus overflows or scanline errors. So I guess that would only happen if there are any issues with this thing keeping up with the data stream that's happening on the bus. Maybe on a 2GS, that's where it struggles because it's faster, running in the fast speed. Not 100% sure about that. And the final thing to look at is T for test. And we have all 16 colors the Apple II can create, along with 80 column text at the bottom, which looks pixel perfect. And that's because we're in a mixed graphics / text mode right now. And with Apple II, normally it would turn on the color burst for the entire screen, including the text lines at the bottom. So plugged into a CRT, the 80 column text would be super unreadable. But here, because this card knows that those 4 lines are just text mode, it doesn't try to do any color decoding in that area. But if we had any kind of graphics in the upper area with high resolution text, normally the text would be super duper fringed. But what just got added to the new firmware, which is what I was just talking about, the alpha firmware I'm running here, should allow something, well, what I call selective monochrome. And let's see if that is actually working. We'll be testing this for the first time together. I'll be using the demo disc from the Apple RGB card because it has several of these different modes on there. Now, one mode that's not yet implemented, I don't think it's implemented yet, is high-res 16 color mode. And I think it's about to show it right now. And if we see an Apple logo that's just all in white, then it's not yet implemented. That is something, oh, it is implemented! Okay, so this is new. This is new for the new firmware. So this is something that this card can do, but not the Enhancer IIe that's in there. What we're looking at right here, and if I hit Control-C, that's just going to stop it there. This is normal high-res graphics on the Apple II, but with 16 colors available to it. It's not using artifact color. If we plugged in a composite monitor right now, all we would see is a solid white apple. But what this is able to do is use some additional parts of memory in the upper aux bank of RAM to create a foreground and background color for cells that are the same size as a character. So right now the entire screen has a background color of black, but then we are getting these color stripes for the Apple logo, and there's no fringing or anything like that because of course it's based on character cells. This works exactly the same way as the ZX Spectrum. Therefore, if you ported a ZX Spectrum game to the Apple II using this mode, you would actually get a perfect representation, except for the colors are slightly different, of the way the color clash works on the ZX. And now what we're looking at here is what I call selective monochrome. Seems like it's not working quite perfectly because you see on slideshow number 4 on the W, there's a little bit of blue there. But the actual screen that we're looking at here is just normal double high res, which is like 562 horizontal and 200 vertical lines or something, or 192 or whatever it is. And what was happening with the text on this card with the release firmware was exactly the same thing that would happen when we plugged a composite monitor in. It would just be really difficult to read because of the color fringing all over it. But the way this selective monochrome works, and I can tell here looking at this for the first time, there's still a little bit of work to be done because I see some fringing around some of the letters. You see around, I guess, 1983, see how it's all fringy and hard to read? That is how all of that text would be. But the selective monochrome works by setting an additional 7th bit, so the top most significant bit in the main memory. It sets that, and that tells the video card that that little section of the screen should be monochrome. And that's why I call it selective monochrome. We have double high-res color graphics on the bar chart there, but then all the text around it should be in monochrome. And on the Video 7 card, it all is perfectly in monochrome. None of that text has any fringing. But this is a really great example of a new mode that was never possible on the Apple II. And it's funny because when the Apple IIgs was brought out by Apple, they added RGB, but they didn't carry forward any of these additional video modes, which is really too bad. That means they never really got used that much. If these modes had been more widespread and more people had RGB cards, we would have more capable and better looking graphics on the Apple II because of it. But it's still really exciting to me that cards like this are at least implementing the video modes that were possible on cards like this. And here's another one of them. So this is the same thing as what I was talking about, hit Control C again. This is HGR, so the equivalent of the regular high-res mode, but it's using 16 colors by setting that background foreground color just like the ZX Spectrum. And there's no color fringing, and it looks, as you can see, absolutely perfect. I have to admit, me as a longtime Apple II person, when I first saw this, I was shocked. This was possible on an Apple IIe all the way back in like 1982 or 83. Now what's really neat is this utility disk, which came from Video 7, has all of the AppleSoft basic utilities on there. Like you load this little wedge basically. Here's another cool one. Another great example of selective monochrome. So we have a spreadsheet with crystal clear text there and then a color graph in the middle of it all. That is just something that's not possible on the Apple II. Well, it is now with this card and obviously with these RGB cards, but I can't believe this is being emulated. This is so cool. I have to put this out there to all the Apple II people out there who have been using these machines for a long time. Did you know that the Apple II could do stuff like this with a card that Apple actually released? Because I sure didn't until today. Literally today is when I figured out that this was possible. One of the other possibilities that maybe would be nice in the setup utility for this is to allow people to adjust the color palette. You could customize each of the color to your liking. Because this color decoding was originally NTSC, there is no correct color for the Apple II. You change the tint control on your monitor and it would change the colors very wildly. In fact, the brown color that is generated by the Apple II is so wildly different from one machine to another that I feel it'd be really nice to be able to adjust those in the menu. So let's take a look at the slideshow here because I think these are some sample photos, or I can't remember what this is exactly. Okay, so there's that Apple logo, which we've already seen. I think these are all like pre-rendered basically, so it's just quickly loading these off the floppy and into the video memory. Okay, and we've seen this one as well already. I'm gonna have to hook up the actual RGB card. It doesn't look like this at all. It looks all stretched. If I recall, this is like a picture of some stones and an animal or something like that. And it's in 16 color mode, but it's definitely broken in the way it's rendering here. So I'll be submitting this as an issue to the folks who are working on the firmware for this particular card. So here's a list of all of the video modes that have been added for the RGB card. Remember, this disk that I'm running is for this card here. It's not for the Enhancer IIe even. And it has this 7 here, which is the foreground, background color stuff, which is implemented on this card. So this is implementing it across the entire screen, right? Much like the Apple II GS. And you're like, okay, whatever, same thing, right? But this is something the Apple II GS cannot do, and it's display color text arbitrarily anywhere around the screen. Well, on the grid of the 40-column screen, but as you can see, it's easily able to do this. Now, this only works in 40 columns mode, not 80 column mode, and that's because it's using additional memory that's normally used for 80 column text to denote what are the 4 bits for the foreground and 4 bits for the background color. But it's cool to see that it's working, but theoretically, people could write software for the Apple II to connect to, say, a Commodore BBS that has color text and everything, and it could render it perfectly using this technique for displaying on RGB cards and on this card. If we hooked up the composite video output, all we'd be seeing right now is just the normal black and white text, no additional artifacts at all. This is all happening inside the memory buffer of this video card right now, which the DVI card is able to snoop on and recreate. Now, of all these special modes that are listed here, the only thing that the Video 7 Enhancer IIe supports is the selective monochrome. You can either make the entire screen monochrome, or you can make parts of it monochrome while you're in double high res. None of the other modes actually work, and that's because that wafer scale chip that's on here, and this is the same one used on the Apple IIc, only has access to that serial bit stream coming off the shift register from the video circuitry. And that extra bit to denote which parts of the screen are monochrome and double high res is available in that bit stream. But the data that's required for the 16 color high res mode or the text in color is not available to the wafer scale chip when it's just reading the serial bit stream off the shift register. Now, as I mentioned, I'd never personally heard of this selective monochrome mode that was possible with the RGB stuff on these machines. And I was absolutely flabbergasted when I put in Desoldering, which is a paint program that I used to use a ton of on my Apple IIc, and I put it in and I first saw this selective RGB actually working. So let's reboot the computer with Desoldering in there, and I want to demonstrate how this thing actually works, and I was shocked when I saw it working, and that was with the Enhancer card. So right there at the top and the bottom of the screen, there is no fringing at all around their logo. And let's just go into the paint program itself. What's interesting is there are 2 versions of this floating around. There's one version that is from 1984, and it does not support selective monochrome mode. And there's this version, which is, I guess, the subsequent version, 1.2, I suppose, that does. So notice what we're looking at here. You see the menus and the mouse pointer there, how it's sharp and there's no color fringing around it? Those vertical lines that you're seeing there are normally rendered as blue when you have standard artifact color decoding, like on a CRT or what. When you're looking at this now, you might think, oh, the entire screen is in monochrome, right? Like it's just running in monochrome mode, which maybe isn't even correct because we should be having color. But if we go to Paintbrush, there are colors right down here. And if I pick blue and we start drawing in blue, we can actually draw in blue. And then if we pull down a menu, notice the menu is in monochrome, but then the color decoding is still working for the color around the menu. And this is what I was talking about, this selective monochrome thing. I didn't think this was possible. And it's very fascinating to see it actually working on a real piece of software. Now, it's funny is I was going through my box of discs and I have this actual Apple II discs here with a copy of Desoldering on it. And this is the original 1.0 version that does not implement the selective monochrome. They obviously added that capability knowing that people were using Apple IIcs and Apple IIes with these RGB cards and wanted to make the program a little bit more usable. Before we take a look at what the terrible color fringing looks like on the text, I'm going to first boot this thing back into the config utility and turn off that analog FX feature. So we're just looking at that pure decoding of the analog color. And I just want to show how unreadable the text actually is. So analog render FX, we'll just disable that entirely. We'll save everything. And now we'll boot into this version of Desoldering that does not support selective monochrome mode. And take a look at the fringing on the text at the top and bottom now without the selective monochrome. Take a look at how hard it is to read this text. So there's that blue background I was talking about, and I'm just using the joystick here, which is why it's a bit hard. Yeah, that's pretty difficult to read. And I have to admit, I used to use this program hooked up to a composite monitor in the old days, and it wasn't this difficult to read. So let's turn the analog FX mode back on, and let's see how improved that looks. Double high res only mode, it's markedly better. It's so much more readable, the text now. So that's a really good implementation of artifact color decoding. It's far better than any of these RGB cards that I've ever seen. Yeah, the way this text now looks, it's fringy, but to be honest, that's kind of how I remember it looking when I had it hooked up to my TV back in the day. This is unfortunately just one of the side effects of the way artifact color works on the Apple II. It just doesn't look good when you have text mixed with graphics. It just gets all fringy and quite difficult to read. But if we just reboot the system on this slightly newer version of DazzleDraw that has the selective monochrome, well, that's gonna make it a whole lot easier to read because we're not gonna get that fringing. Let's load a photo off here. I think my disk is damaged, but hopefully it is able to load this. That's really curious. So this modified version of DazzleDraw loads this in monochrome mode. Why? Thing is, we definitely have color on this thing. There's some color right there. So let me deface the butterfly here. And you can see as I draw, there's little bits of color around it that are suddenly becoming visible. I don't know why it's decided that the picture itself is monochrome. It looked like to me that the zoomed in area was in color. Let's zoom in on a part of it here that, yeah, there's color. So I'm not sure what's happening there. But that's a little idiosyncrasy for this particular modified version of DazzleDraw. All right, next thing I have to do is I gotta try a copy of Fat City on here. There's no such thing as an Apple II video on this channel without me testing out Fat City. That's gonna be kind of loud. I don't have a volume control on the IIe to turn down the speaker, so there it is. But that color decoding looks absolutely perfect. I have no complaints for the way that looks at all. This is completely understandable that it's got color fringing on it. See around your name, the U there, it has a single pixel riser and it's just green. And you see purple on other letters. That is how it would look on a monitor, although it's probably slightly exacerbated on here. So I think what I'm gonna go do is I'm gonna turn on the analog FX mode on all video modes, not just double high res, so we can compare the way that text looks there. So this mode is now enabled. All right, so on this screen, it looks basically the same. I don't even know if I can notice any different whatsoever. Actually kind of has me wondering if this mode even does anything in the normal HGR mode, high-res mode, not double high-res mode. No, this looks exactly the same. Okay, so it's not actually doing anything here. It's my personal opinion that if this were hooked up to a real CRT, the color fringing around the text would actually be a little less severe than it is here. I mean, it's no big deal. That's just how it looks. It's really because color information on NTSC is lower resolution effectively than the actual high-res image that's underneath it, the monochrome image. That means that when you have a single line there that would be showing up as green here or purple, it really wouldn't be that clear on a CRT. The color would be kind of washed out in that one spot, which would actually make the text a little bit more readable around like the W's especially. Please don't misunderstand my critique of the way it looks there as a dig on this particular product. This is the way the color decoding looks like on everything. The Apple II GS looks exactly the same, and that's color decoding that Apple designed and implemented in hardware, and all of these RGB cards look just like that as well. All right, so what I haven't done yet is I haven't talked about where you can get this hardware. I mentioned that this is an open source project, so you can totally go to the GitHub repo here, which of course I'll link down below, and you can download the Gerber files and make these cards yourself. There's even a version of the card that has both the VGA and the HDMI connector available, and I think you just have to change the firmware depending on which one you're going to use. And there's that extra pin I was talking about for switching in the different character set. The fact that this is mostly through-hole construction means it should be very easy to build. You just have to figure out how to get the HDMI connector on there. But the rest of this stuff is just easily obtainable off-the-shelf parts. So building it yourself is completely within the realm of possibility. For Raspberry Pi Picos, you can pick those up anywhere and they're $5, but you can even get them from AliExpress for like the clone versions, and they're around $2 shipped. And they even have versions with USB Type-C on those. So you could build one of these very, very inexpensively. There's a separate repo that is for the firmware specifically, and it talks a little bit about how it was possible to even get the HDMI, or rather the DVI signal, out of this thing. You don't have any more analog conversion, so that's why you get absolutely pixel perfect conversion. And you can plug this into your most modern OLED TVs or whatever and look at your Apple II in a way that you never saw before. It will almost look like emulation for the most part, even though it's running on real hardware. There's even firmware available now for Raspberry Pico 2. It doesn't add any new features that I'm aware of. There's more GPIO I/O lines and stuff available with the RP2040, but the Pico 2 is out, and yep, the firmware is being built for it as well. So if that's all you can get when you go to build one of these, no problem. The firmware is already there for you to build. So there's a section here on the firmware repo that talks about, with this block diagram, how this card is working. And we know it's snooping the data bus, but how is it doing that and outputting a DVI signal as well? Well, it's using the dual card nature of the RP2040. That first core is used for all of the memory shadowing and snooping of the bus to look at all that activity that's happening with the 6502 right into the video memory on the Apple II. And then it's using that second core to generate the DVI signal, the TMDS rendering. I mean, that's got to be some really careful coding to be able to pump out the data fast enough that you get a nice digital signal right out of this. And when you look at this diagram, you can kind of see here that with this core 1, with some really careful programming, additional video modes can be supported, potentially including the Apple II GS video modes. And this would give, very inexpensive HDMI output on the Apple II GS as well, which is just amazing to me. Scrolling down a little further, here's an example of that analog effect turned on and off. And you can kind of see copyright 1988 is just a lot more readable with the analog effects turned on. And that's just what we saw when we looked at Dazzle Draw as well. And I never went into the custom font loader in the configuration utility, but here's a screenshot of it. It looks like it actually can load ROMs directly. And it goes on to tell you how to connect it to that switch for your European machine so you can get access to both fonts. And then here's a screenshot of the Apple II desktop, which incidentally does use monochrome mode, and that already did work. It's not selective monochrome, it's monochrome on the entire screen, and that works in a different way. I think it uses one of the enunciators or something on the joystick port to enable this particular mode. Theoretically, now we have access with these types of cards to selective monochrome mode. The folks who maintain the Apple II desktop project could add a little rainbow color logo for the Apple there, and maybe even color backgrounds without making the text completely illegible, which was unfortunately the problem before we had selective monochrome. It was either all monochrome or not monochrome at all. So now that's totally doable. And lastly, let's talk about if you want to buy one of these. Now, I did a quick Google search and I see that this one seller has them for $55, although it says out of stock. Here's a different seller on Tindy selling them for $43, and it's actually, well, there's one in stock, at least at the time of this video. And at least at the time of this video, I went to Chris's website here, 8bitdevices.com, and there was no store there yet. It looks like it's coming soon, so I actually don't know how much Chris was selling these for at VCF, but I'm assuming that soon Chris is going to have these available as well. Just a note, while editing this video, I've been chatting with Chris via email about these cards, and Chris mentioned that one of the versions of this card that's sold on Tindy is not laid out in a way that is respecting the impedance matching that you need on the traces for the DVI signal. And Chris's new version, which is version 3 here, slightly size reduced versus the one that I have, which I think is version 2. Chris was telling me that the signals that come from the Raspberry Pi Pico for the DVI signal need to be impedance matched and also specially managed with the traces running next to each other. Chris tested his design on some test equipment to ensure that the eye pattern that was being produced was perfectly correct for this high-speed DVI signal. And when he looked at the one that he bought off Tindy, which is this one right here, well, it was a mess. And while it was working, it could easily have issues with longer cable runs or certain displays. I took a look at the renders of the official versions of this card that's available on the official GitHub repo, and it seems like at least here, the capacitors are placed in the correct position to hopefully ensure you're going to get a good eye pattern. Chris also mentioned in the email that he's working really hard to get his store online, so perhaps by the time you see this video, his store will actually have some stuff for sale, including his new fancy new final design here with the correctly matched output pairs for the DVI signal. But let's be honest, when you look at the through-hole version of this, I think it'd be pretty easy to assemble these by hand, and you can just order the PCBs from one of the companies in China and build up one for yourself and a few for friends, and then You know, you were talking like $5 each if you buy the Raspberry Pi from AliExpress as well. So I think that's going to be it for this video. I absolutely freaking love this project. I still can't believe we're getting DVI out of an RP2040. It's kind of mind-blowing. And I feel that now that this thing is out there, this is going to open the floodgates to other projects using the RP2040 to give us DVI or digital output from all sorts of retro computers. The monochrome Macintoshes is a perfect use case for something like this as well. I think there's enough horsepower inside one of the cores in here to digitize the video signal that comes in from the motherboard on a Mac SE or whatever, SE30, and then you can get a nice digital video output as well. And you could do it all for just a few dollars. And to be honest, you don't even need all these level shifters if you're doing that. You can just go right into the RP2040 and have just a little board that could output the video directly. That's just amazing. I am so excited for the future. It's really exciting with the Pico 2 being out, the new version of the RP2040. I forgot the number, 2350 or whatever it is. It has more RAM, it has more GPIO lines, and that additional RAM and horsepower is going to allow stuff like on the Pico Gus, full Sound Blaster 16 emulation with OPL 3. Right now it can only do the old Sound Blaster with OPL 2 because there's just not quite enough horsepower in there, but with the new one, Sound Blaster 16 with OPL 3 should be doable. And theoretically for say the Apple II, why can't we have the entire Mockingboard emulated on an RP2040? So instead of buying that card with those hard to find chips, we could just use one of these and get speech and get multi-channel sound and everything right out of the Apple II. It's freaking amazing. What a time we live in, what a time. And it's amazing that people are working on projects like this. Like I said, it's a total renaissance. Okay, I think that's gonna be it. If you like this video, thumbs up. Huge thanks to my supporters. Their names are scrolling beside the screen to make it possible that I do this full time. Thanks very much, Chris, for giving me this card at VCF Midwest. I'm glad to have seen you again. And like I said, I didn't even know about this project and I think it's freaking awesome. And I guess that's it. So stay healthy, stay safe. I'll see you next time. Bye-bye.